All right, cool. Hey everyone. Welcome to the final presentation for the ZkNoid lottery. This is the proposal, the second proposal from the team. So I'll pass it over to Alex and team.
Yeah.
Over to you.
Hi, I'm Alex from ZkNoid, and so today I'm going to present you the milestones that we achieved during our proposal that we've done 2 months ago, and let's see what we have achieved during this proposal. So within this proposal, we have placed several goals that we want to achieve. First is the SDK and the game store. We want to improve hugely SDK so the new developers can build more easily new games and improve documentation and also introduce several new features that comes with a new protokit version. Also, we wanted to provide a lot of content. We wanted to improve the documentation of Mina more to describe to the new developers how to build on Mina, what they can use, how to easily do some stuff, how to test, and all this stuff. Also, we wanted to participate in several events. This is as Global Online. We were judges there, and also the events on the as Global Singapore. And the main purpose of this proposal was the lottery game itself. So in the previous proposal, we started to develop in lottery games. We have found several more things that we need to do to make lottery fully works. And this stuff is like gift code mechanism. We wanted to prepare contracts for audit and audit them. And improve the backend so that it will be robust and fully working with the full duration of the lottery. So within the context, we have developed many articles. It consists of several different types of articles. It's the information about our SDK, how developers can build using our SDK, and how easy it is to build with it. Also, we have several articles focusing on the development of L1 Mina itself. So, for example, we have 5 articles about action and reducers. And total is 8 articles that was prepared. Not of them is fully published right now, but all of them are at the kind of final stage of preparation. Most of them is deployed on the Medium page. Next is SDK is and store. We have migrated to the new protokit version. It's allow of the persistent storage, and also it's changed the way contracts is written a little bit. So we have to rewrite the full code that we were provided. So the developers that using our SDK can get the full power of the new protokit. Also, we have improved our store, so it supports L1 games and L2 games at the same times, because previously we had the problem that L1 and L2 had to be deployed to the different domain. Also, we hugely reorganized documentations. We found the problem that the documentation was kind of chaotic, so we redesigned it and implement, so it's now should be more clear for everyone what we're doing and how to build on us. And also we done some configuration also for the developers to easily deploy the code and use it on the testnet and production. Within a L1 lottery, we've made a huge step in the lottery development. We have redesigned the contracts itself. We have created a backend and then made it robust enough to manage the high load of the testnet. We have provided a testnet for the lottery. It was at first maybe a little bit not so stable, but at the end everything was working perfectly, and the winning ticket was produced successfully, and the users can buy tickets also without any problems. Also, we have prepared the audit. We have done the documentation for one lottery to successfully pass the audit. We have received the audit from the XRP company, and also we have dealt with pretty much every um, issues that they found, and there was some issues that was not critical, and it was like bug, not it's feature, not bug. Um, Within the events, we have participated, as I told, within a two hackathon. First one was at Global Online. Within this, we got the 6 projects. They were quite a good quality, and um, also we had 3 more projects within as Global Singapore, and we were there in person. We were helping developers to build the products um, not only using our SDK, but also using the protokit itself and L1 also. With as Global Singapore, we got 3 more projects. It's total of 9 projects, and currently we are in close contact with them uh, to push the development further and to list on our store. I think that's in general everything I wanted to say.
Cool. I mean, I have a quick question. If you could go back and walk us through your microservices architecture and then how it operates.
Yeah, with the microservice architecture, it's well, I think it was somewhere in the beginning. Yeah, it's like we have a backend for the lottery, and for it to fully work, we need to also make some transaction from our servers, and some stuff need to be done on our server. For example, we had initially distribution proof that is a huge proof that is provided by user, but it's the same proof for every user, so it makes sense to make it to create it on the backend and then just send to users. Also, so it's one microservice that's do the distribution proofing. Other microservice was creating the commit reveal scheme for the winning ticket generation. Other microservice was responsible for the providing the right Merkle for the users, because we don't users on the front end, they don't have a full Merkle list of the tickets, so they initially can't create a proof with these tickets like for get rewards, because they need to prove for the smart contract that the ticket is included in the Merkle list. So our backend is stored all this Merkle tree, not Merkle list. So backend stores this Merkle tree and sends the right Merkle path to the user. And all is done within the microservices, yeah.
Right. So you've taken maybe which was something earlier, a single monolithic backend, and you split it into multiple services right now.
Yeah, we had several problems with monolithic architecture, so we moved to the microservices, yeah.
Hey, Andre.
Yeah, let me show how it works. We really split all the monolith architecture into microservices and received several benefits of this. Let me share my screen.
Okay, I can stop sharing.
Yeah, please stop.
Andrew, your microphone is off.
So here we can see the microservices we implemented. First of all, we have the IP server that is the main microservice of the project. It stores the state manager. It executes all the background tasks. Also, we have a reduced prover microservice. This microservice in charge of generating the reduced proof of the round. So when round ends, the reduce prover microservice generates the reduce proof for it. We have these two microservices are separated, and if something goes wrong, for example, some microservice is stuck, or it have like state issue while fetching data from archive node, it's reloaded by AutoHeal service. So this architecture is much more reliable compared to the previous monolithic architecture, and it shows the great stability during the testnet.
Cool, awesome. I also had a question on the gift code mechanism. Was that implemented, and could you show that, please?
Yeah, it was implemented. I think the best way to show it is using.
Yeah, I can share my screen and show how it works in practice. Let me share my screen.
Yeah, it's like gift code mechanism, and also the transaction reordering was last part that we were done, and it was completed last week. So. Yeah.
Andre.
And here we can access the gift codes. So here I can generate
Is it
the
just
gift
me?
code. Here, what do you mean?
Sorry, Andre, you're breaking up a bit. So I was just checking with the team if it's my connection or yours.
Yeah, here are the gift code section. Here are the existing gift codes are located. And if I want to buy a gift code, for example, to share on Twitter, to gift it to my friend, I can buy a gift code here. So I selected two gift codes here. I have total amount 20 mina. I can pay using my wallet. First of all, it requires a signature, and then it creates a DevNet payment. I confirm the payment, and payment goes to the network. We need to wait for the finalization of the transaction, because otherwise someone can make a payment, then substitute the transaction and receive the free ticket. So you need to wait for the payment processing. You can see here as the promo codes I just created, they're in the payments processing state. I can copy. I can't use this for now, but I can copy some that is already ready to use. For example, this one. I go back here and I use gift access code. I enter the gift code here. You can check this that we have validation. Only correct codes are passed this check. I tap the submit button, and I can choose which ticket to buy using this code. So this code gives the ability to buy a ticket. I enter the numbers I want. I confirm ticket number, and here I can receive the ticket using my gift code. You can see the discount here. I got the full discount because I use the promo code, and I click receive ticket here. Also, the signature is asked here. I sign the message, and I have the transaction executed. After a while, backend will make the transaction, and the ticket will be bought. And also you can see here that this promo code is used. So it was used to buy a ticket for me. After some time, when transaction is executed, I will see my ticket here in this section.
Cool, awesome. And I guess the question is, are these ticket codes saved only on the back end, or is there like a smart contract check.
There
for
is
the
an
code.
interesting system. We can't fully store it on smart contract because we need to store the original of data somewhere in order to use it. And we implemented the following approach. The codes are generated on user front end, and the hash of the codes and the random bytes is sent to the backend. Also, the signature is sent to backend that identifies that the following user creates the code. The code and the signature is stored on the backend, and the code is used like a private key and considered to be a private information that is stored on a client front end. And when someone uses the key, when someone uses the promo code, he also sends the hash of the promo code to the backend. Hash is verified. It's verified that transaction is executed on blockchain, that it's finalized. And in this case, a ticket is bought by the backend worker.
Gotcha. Very, very interesting. I think it would be nice to have when you're happy to provide some documentation on how that works.
I guess, yes, maybe we can create an article in future to describe how this works.
Mm-hmm. I guess my one last question is also on, you mentioned you have made optimizations to reduce the proof. Could you speak a little bit more on what that process was?
We faced a challenge that if we create a recursive proof many times, after some time, the whole process is stuck. We face, so there are instability problems when we just create a proof one by one and generate the whole proof. Instead of this, we we migrated to the sequential proof generation. So we store the current proof in database, and worker tries to create the next proof to include the next ticket to the proof. If it succeeded, the next proof is stored in database. But if something is stuck or servers go offline or something strange is happen, the proof of the current state is stored in database. And when background microservice is reloaded, the proof generation continues, and this greatly improves the stability of the proof and of the lottery. I can share how it looks like in database. I'm sharing the screen. So in database, you can see the reduced proof. It's the proof accumulated. And we have the last reduced ticket. It's the current index of the proof, of the recursive proof. And the proof is accumulated here until the last ticket is processed, and the result proof is used instead of generating the whole 23 iterations of the proof in one place.
Cool, awesome, and yeah, I don't have any more questions on the delivery itself. So I know you guys are still writing out the remaining articles and the videos which were planned as part of the proposal. So I look forward to them being published in due time. So thank you very much for joining, for your time and sharing your work with us.
Thank you, Harish.
Thank you.
Thank you.